Cool. All right, before we get started, I wanted to make everyone here aware of an opportunity for free money. Woo! Free money's good, right? Is paying for school fun? No, I feel like an infomercial now, so I'll stop. I'll just talk about what it actually is. So as part of, ASU, if you're not aware, we're actually a nationally recognized center of academic excellence in cyber defense education and cyber defense research by both the National Science Foundation, the Department of Homeland Security, and I believe the National Security, what's the NSA stand for? Administration? Agency, there we go, yeah, that makes more sense, cool. And as part of that, we have a super cool program. So we just got a new grant from the National Science Foundation. I think it started about 6 months to a year ago for, I think it's $4 or $5 million to fund your studies. So this, I will say, limited time offer in the sense that it's not insanely limited. The idea is the federal government, do they have security problems? Yes, they have security problems. Everybody has security problems. As we're going to see more and more, all of these security concepts originated basically in military and government contexts. That's where a lot of this stuff came from. So they are very interested in getting really good people like yourselves into security. And so part of the way that they do that is to fund your studies. So the basic idea is so you have to be a resident. So for those of you that are not U.S. residents or U.S. citizens, I apologize. This will not apply, but we'll be back on in a second. And basically the idea is for every year of your college that the government pays for you, so you get, if I believe here, full-time tuition and educational related fees. So you get your tuition paid for, you get health insurance reimbursements, you get up to $4,000 per year of a professional development, which of course I know you can see, with a professional development allowance, which allows you to go travel, do kind of cool travel stuff, a book allowance of up to $2,000, and a stipend depending on what level you're at. So not only are they paying for your school, they're actually paying for you to go to school, which is a pretty cool deal. And all they ask in return is that for every year of your school that is funded, that you go work for the federal government for a year. So if you get 1 year funded, you go work for the federal government for a year. If you get 2 years funded, you work for the federal government for 2 years. I think that's the limit unless you're doing a 4+1 program. I think they can do 2 undergrad and 1 master's. So this is at the undergraduate, master's, and PhD level. Yeah, it's actually pretty sweet. And the really cool thing to think about here is once you've done this, so I know several students who've gone through this program. Some of them have gotten jobs at the NSA where they can't tell me what they do, and an FBI agent comes and interviews me as part of their background check, which is always a super fun process. But the really cool thing is, so let's say, not only are you giving back in, they're going to pay you, right? So it's not like a free job, right? You're getting a job in the federal government. But if you decide that's not really for you, as soon as your time's up, then you can go back into industry with all this insane, awesome experience of working in the public sector. Specifically because a lot of these jobs require some kind of security clearance, which the federal government will pay for you to go through that security clearance process. And then once you have that mixed with your experience, that makes you very attractive to private companies that pay you a lot of money for those abilities. So very cool program. Any questions on this? Yes?
Is this available online somewhere?
A super old version is, yes. I'm working on getting it up now. I can post this, like a link to this PDF or something on the Piazza, but it will be up on a new website very soon. If you're interested, please contact me. I will be happy to connect you to who you need to be in contact with. Yeah?
What would it take, start?
Louder, huh?
What would the start?
I think it's very quickly. I mean, if you applied, the deadline I think is tomorrow. No, I don't think we can retroactively cover stuff, but I believe Dr. Yao put this is very, yeah, so basically, so we can actually start, what's this? spring 2019, so that'd be next semester. So for the upcoming semester, we're going to start reviewing applications if you submit them by November 7th. But as soon as you start applying, people will be in contact with you, and so we can get that started. Yeah? Yes. I do not know the specifics. Steve would know, Dr. Yao would know better the specifics there. I think you may still be on the hook. Well, I actually don't know. I would say my intuition would be probably work for a year because working for 6 months is hard anyways, right? So that's my initial feeling, but I don't know the official rules because us selecting people and giving them money is our job. The contract you sign is not with us. I don't want you to break your contract with the government, but that's something you sign with the government, not us. So it's not like I'm going to come down to your door if you quit within 3 months or something. Yeah?
Is there any further research or internship opportunities included?
There is. So as part of this program, let me see if I can find it. This is about applications. So there's part of this is that you'll participate in government internship programs. So in, I believe, around the January-ish time frame, there's a job fair in DC where all the people that are part of this scholarship for service program go. And so you get to submit your resumes to a lot of government agencies that they can then see if you want to do that. So yeah, the idea is you work in the summer for an internship for a government organization, and that would try to help you, just like a normal company, help you find a place that you work well with.
Is there a list of those companies or no?
It's not companies, they're all
government organizations.
I don't, I'm sure there is somewhere, maybe in their website or something. But yeah, it's all kinds of people. I mean, I think we had some people who were going to go to Hawaii with one of the Army divisions there. We have people in Maryland doing secret stuff, all kinds of stuff. Yeah. Any other questions? So I'll post this. I don't take up too much time, but I want to make you all aware of this, especially for, I think, juniors. This is kind of you're at the perfect time here to apply. If you're considering 4+1, even better, because you can do undergrad plus a little bit of grad school funded too. And it's pretty fun. Cool. All right. So then, on to class. So back to matrices. Cool. Okay, so what was the matrix model of access control? Yeah.
The left side was users, or I guess the left column is users, and then the top row is objects.
Subjects and objects, but yes, the way we've been talking about them has mostly been users. It could be a process, it could be any kind of other thing as well. Yeah. And then what's inside, so for a specific column row, yeah.
The rights that those subjects have on those objects?
Yeah, the rights that those subjects have on those objects. So this means that whatever for the system that you can do has right R2 against G, whatever that means. I mean, it depends on the specific access control system. So we talked about it right at the end, yeah.
So we say rights, privilege, access, same thing, right?
I think those right now, especially at this high level, I mean, we're talking more technically, like I changed users to subjects. So we have subjects, objects, and rights. So that's how we talk about them, but those are very similar types of things. Like, yeah, the rights, access, privileges, I think those are all. So what's the benefit of thinking about and modeling access control using a matrix like this? Yeah.
We immediately know which subjects have rights on which objects.
It's super easy to determine who can do what on what objects, right? Because you can say, well, does U have right R1 on G? You look it up, you look up UG, and you say, nope, does not. What's the downside?
Doesn't scale.
Doesn't scale, right? How so? How doesn't it not? How does it not scale?
N squared.
N squared?
I think the number of users. And
Yeah, the more stuff you have, the bigger this table gets, right? And every time, and then I just mentioned that rows can be users or a process. And so do you constantly having a process being created and deleted on your system? Yeah, what kinds of stuff? What was that?
Concurrency, right?
Yeah, but all kinds of processes do that, yeah. An update, yeah, so some kind of background process that's checking if your computer's up to date. Every time that gets created, you have to create a new row in this table where you have to fill out all of the rights that that process has. And then when it goes away, you'd have to delete that. And you'd probably, and because every subject is also an object, you'd then also be creating new columns and deleting them all the time. Yeah, every time the user types in a command, every time they, this gets, so not only is it not just big for a static system, but we have to always remember our systems are dynamic and things are changing. So how do you solve this? Yeah.
Usually what they tell you in classes is like if you have a 2D array and you want to make it better, just use a tree or something.
Okay, so use a tree in what sense?
So maybe have like a tree that describes the hierarchy of access, so you have levels.
Okay, so maybe if we order our rights in some kind of way that we can give hierarchical more or less rights.
Then you can have some kind of inheritance that kind of like simulates.
So you make it as convoluted as any object-oriented programming project, yeah.
Generalized things. So for users, maybe instead of going individual users, put them into various groups. That way, that kind of cuts down on that. And then for processes, maybe kind of divide that into system processes, user processes.
So we can try to group things, yeah, so we can try to group users, so rather than having one row for every single user in the system, group the users, group process. What about the objects? So think of, oh yeah, please.
I mean, you could group those as well, depending on what they are.
You could group them? Like how? How would you group them?
Like things that should have like public access versus private.
So maybe the hierarchy kind of model, but turn the objects into some kind of a hierarchy, right? So you have the set of all, I mean, I guess, how do you know which is in which set? You still have to like put them in there, right?
Yeah, you
Right.
can organize it.
Yeah. So, and then I guess there you're kind of explicitly saying if an object is in the set public, then it means that any subject can read that object. So you're not actually specifically spelling out every single user on the system can read that. How do we actually implement this? With difficulty, yeah, I guess that's most things, right? You do it difficultly, it's hard, and you do it carefully, and maybe you can make it work. But think about like an operating system. How do you actually implement this? Like, so how would you implement this? So let's stick with this the matrix model. Big matrix, big table.
Yeah.
Yeah.
There's the access, in Linux, you
Mhm.
have like the read write.
No, but how do you do this? Okay, let's actually, good question.
That kind of.
How, so does the Linux and Unix access control model implement this? Not really? Kind of?
I mean, you can model it this way.
Ooh, you can model it based on this. Does it actually implement that? So does every file have access options? What access options does a file have? World read, world write, execute. By world, what is it? User, or the owner, the group, and other.
Other, yeah.
But does that mean you can give a specific user access to, just one user access to one file?
No, you group them all together.
Right, so essentially you're collapsing, right? So if you think about it, the Unix model doesn't actually implement this model. So let's talk about that. We'll dig into that a little bit. We'll come back to some of the other questions we talked about. So in the Unix model, so if we think about it, users are actually nothing really. Why is that? There is no spoon. There are no users.
It allows you to group the users as you would processes by rights.
You definitely can. But so you as a user on a Unix or Linux system,
It's a folder, it's like directory inside user directory.
there is a user directory associated with every user. How do you do stuff on a Unix machine? So think about, like, I know it sounds, but if you think about it, right, we talked about subjects are things that do things, that operate on objects. So when you operate on an object, how do you do that? You do what?
Command.
You type in a command. What does a command do?
Process.
Starts a process. That's the name of that command that carries out whatever logic you wanted to have happen. So since we're getting there, I'm going to, of course I turned off my VM, but there we go. I'm going to awkwardly move this up so the recording's going to get all weird. I probably need to, I don't want to mess with that. I mean, I do want to, but I don't want to make it worse. Application not responding, always the best. Okay, I think I can spin up a Docker instance real quick. Okay, cool. So here I am. Can everybody see this on the left screen? Is this better? Is black on white better or white on black?
This
This is better? Okay, we'll stick with this for now. Okay, so users on the system. How do I figure out what users are allowed to access the system?
LS.
Yeah, users. Why do I find the users on the system?
Is it in like a file somewhere?
There's no users. So EDC, PWD, this is a file that contains all of the users on the system. So here we have a user root, we have user daemon, bin, sys, sync, games, man, LP, mail, news, UUCP, proxy, www data, backup list, IRC, huh. Nats, that's interesting. I've never actually read through all of these before. Nobody, underscore APT, systemd network, systemd resolved, because you definitely want those to be separate, UUIDD, and message bus. So these are all the users on the system. But, like we just talked about, so how do I list the current files in this directory?
LS.
So I do ls. What is actually happening here? Is this some kind of magic voodoo?
Yes.
No, there's no magic, there's no voodoo. What's happening here?
It's running.
When I type in ls and I hit enter, what's happening? What am I even typing ls into? Yeah, some kind of shell. How do I, actually, can I figure out what shell it is?
Who am I?
Huh? PS, so I can look at what process, all the process that's running, so I can see bin bash is PID 1. It's running as user root. So when I type in ls, what's happening here?
What's the files on there?
Well, what's happening? So when I type in ls, where's that going? Where's that input going?
Into the shell.
Into the shell, specifically into bash, specifically exactly to this process here that's running. And when well, this is Docker, so I'm not SSH'd in, but if I was SSH'd in, it would, the SSH daemon is listening on port 22. It sees somebody logging in. When they log in, it checks their username password with etc shadow, not etc root. And if that is, then it creates a shell for them as their user, and then it matches up that the standard input to bash is the input that they type in from the network. So I type in ls, then I hit enter, what happens? How does bash know what to execute? What happens if I type in foobar? Why doesn't that do something?
Binary.
Yeah, it does. How does it know? But I type in ls.
Yeah, there's a file that maps on the.
There's nothing called ls in my directory.
There's a path variable.
Which?
So the path variable, what does bash do with this path variable?
It'll look for ls
looks for ls in every single one of these directories separated by a colon. So it'll look in user local sbin ls, user local bin ls, user sbin ls, user bin ls, sbin ls, bin ls, which should finally find it. And if you do which ls, it'll tell you which one it's going to find and execute. So it's going to tell you it's running bin ls. This is why when you compile a program, how do you run it? You just say a.out. /a.out, because you have to give a.out does not exist in any of these directories. And you'll notice that the current directory dot is not in your path, and you definitely do not want that to be, which we may get into later, but that can be a big security problem. Okay, I type in ls, so bash has to first figure out what command I want to run, which in this case is /bin ls, or if we give an absolute path, we can say I want you to execute bin ls, which it'll do. And then what does it do? So it says, okay, I found bin ls. What does it do? Yeah.
Check if the user executing it has the correct executable permission bit.
No, ls can't do that. Yeah, why not? So, if we go forwards a little bit, so what happened? Okay, so I type in ls, bash figures out what thing I want to execute /bin ls, something happens, and then what actually lists whatever directory or information that I want? Probably technically yes, but not quite what I'm going for. What? Yeah. So, what lists out this directory? Like, where did this input come? Where did this output come from?
ls?
ls, which is a program. It's an executable on disk. We can look at /bin ls. We can see that it's an executable, and we'll get into the permissions in just a second. Oh, that's interesting. 1337, 92 bytes of ls. And so if I do something, this is not going to work. Oops, sorry. I just want to do this because this will be easier. Okay, so if I run a screen terminal, well, okay, now I've broken everything. Probably want to run bash, but that's okay. All right. So all I want to show here is if I do something like cat. So cat, if you just run it by itself, what's it doing?
Just waiting.
Standard input.
Just waiting for whatever you type in on standard input to put on standard output. So you can think that you have a really nice friend. Hello. And if we go over here, we can see that if we run ps aux, we can by the htop. No. I broke everything. Okay. What do I want to do? Oh, ps. Okay, we can see that there is. Okay, here we go. And that was my scrolling. Okay, we can see here that it should be here, right? Yeah, so process 174 is a process called cat that is running. Just like there was a process bash that was running. Does anybody remember off the top of their head how to do the parent-child relationship in PS?
Oh, it's like F or something. I think you want a tree, right?
Yeah.
It's like F. Not dash F, just F.
Ah. Nice. Okay, cool. And then if I make that smaller, it'll actually make sense. If I can. I've rebound my keys, I have no idea. Okay, we are stuck at this zoom in forever. So that we can see that, so we started with the original bin bash, which then actually executed screen. So screen is running, except screen is actually will constantly be running without my bash session, which is why it's not a child of bash. And then under there, we see that we have a bin sh where I'm running cat and a bin sh where I'm running psauxf. So this is two of those different applications. Anyways, the point being that my sh, my shell in the other window of screen is running cat. And so if I go over there and kill it and I rerun this command, I should see that it goes away. And it did. It went away. And if I kill all of this, get out of the screen, screen terminates, psauxf, that's handy, thank you. Now see that all that went away. So the only thing that's running is bin bash. Okay, so we know that there's a process. When we type in ls, eventually what happens is a process runs that does what? Yeah, when you run it just by itself, it lists the current directory. What happens when you type in ls-la?
What's the details? All.
Yeah, so these are these special arguments to bash?
No,
it's
special
special
arguments
arguments.
to LS.
No, special arguments to ls. So all bash does is actually look at whatever you type in, which is just a string. And have you taken 340 yet?
Sort of.
Are taking it?
Yeah.
Awesome. So basically, you use compiler techniques to parse the string and separate it by spaces so that you can figure out what's the command, the first argument, and then what are the arguments to pass to that new program. So the entire thing is this is a process, or that is how. So this is what's happening. So this is an important concept to remember. You are doing, what am I actually doing on this system? Nothing. I'm giving input to bash, and then a process runs to then do whatever I wanted to do. Okay, now if we step back for a second, how does bash actually start a new process? Can bash do it? Is it a special process?
No, I think it has to go down
To where?
one level.
To where?
Level.
To the kernel, to the operating system, right? The operating system is what's keeping track of every process on the system, and it's the one that will execute it, and it specifically is the one that's going to do that check of can you actually execute this. Like if I just did /bin, what should happen? Nothing. Why?
It's a directory.
It's a directory. Not only is it a directory, well, it doesn't matter that it's an executable directory, but yes, it is a. Well, I have to come up here. Anyways, it is a directory. It's not executable. So this error, I believe, should come from the kernel, but I'm not actually 100% certain now. So how does the operating system know that you can execute binls? So how do we parse these first, what is it, 6, 9, 10? How do we parse these 10 things here, the first 10 output of ls-la?
How do you like understand the interpreter?
Yeah.
Oh yeah.
Not like write a parser to do it, just understand it as humans.
The first characters for the directory, and then the precursor.
Not quite, we'll get that.
Yeah.
This is something special, which we'll get to. And then the next three are what?
It's like 3, 3, 3. So then that's the user.
Owner. Yeah.
Owner group.
Yeah. Owner, group,
Group and
other.
Yeah.
So this is read, write, and execute, which means that the owner of this file can read, write, and execute it. How do we know who the owner is?
Tells us.
It tells us where.
Group.
Yeah, after here, I don't know what this is. After here is the owner is root and the group is root. I know what a lot of these things are, but I don't know what that is. Here's the number, the size of the file, the number of bytes, the date it was. Probably modified, I'd say, but yeah, I'm not 100% certain. And this tells us what the file is that we're looking at. So this means that root can change binls. The group root can only read or execute. And everyone else on the system can only read and execute. Why don't you want anyone on the system to be able to write?
Yeah.
Yeah, so you can't change ls. I mean, you could. I I'm root on this system, I guess I could change it. But fundamentally what that means is then anybody could write change ls, and why is that actually a big deal? So when I'm running as, so I guess I just destroyed the concept of me, which makes explaining things slightly more complicated. But bash, yeah, please. I can't hear.
Why is it a security hazard?
Yes.
Because that's like a basic functionality. You don't want anybody messing with what you're expecting to do.
Someone can put whatever code they want right there in ls.
Yes, and what, so, okay, all those things are true, but to understand what actually, why that's actually a problem. So if I do PSAUXF, so bash, okay, so the thing we said is, okay, so users are nothing. But how does the operating system check? So we just saw that binls, so if I do, let's see, what do I want, nobody, and I think I need a shell. Okay, so now I'm running as user nobody, right? I'm nobody, no group, no group. So should I be able to change binls?
No.
Permission denied, that's good. Were any of you worried that I was going to be able to change it? No, so I can't do it. I can execute it, but the question is why? So what's the difference between, so I'm running two different bash sessions here. What's the difference? How does the system know, or how does, because where does this output come from? Does this come from Linux? Or the operating system? Bash. There's just bash. There's just a bash prompt. So how does bash know that I am nobody? I did log in as nobody, but
So it doesn't.
Session, like, as you said, the user, that's open.
so what is the output when we did PSAUXF? What's the output here? And here it's a little bit nicer because you have column headings. So you have user, the process ID, the percent of the CPU, the percent of memory, I don't know, something about the virtual size of something, another thing, more stuff, time, command. The important things are command. So what does this mean? So what does the user mean here?
Who initiated the bash prompt and then ran the command?
Yeah, kind of. I mean, it's who initiated that bash prompt, or it's really metadata attached to a process that says what user, you can think of, owns this process. And that is what is used on all the authorization checks. So the fact that I couldn't, as nobody, edit binls, I can even try. Bin, there's no way bin is installed on this. No. Yeah, so I can try to write to it. And Control W, name file right, error, permission denied, which is good. Exit, save, modify buffers, absolutely not. So, why is that? Because bash, well, bash ran nano, and they're all running as user nobody, and so the operating system, when it says, can this process, remember, not the user, can this process change this file or write to this file? The operating system looks at the file and says, well, who are you in relation to this file? Are you the owner? Is nobody the owner of this file? No. Is nobody the group of this file? No. No. Therefore, it must be other. Can others write to this file? No. None.
So,
Yes.
if I understand correctly, the process, each process holds a reference to the user that initiated it.
I would say it slightly differently, but yes. I would say that each process has metadata associated with it. The important thing is, where do you want to put that information? If it's just in the process itself, the user could change it or modify it. So that's information kept in the kernel, where it keeps track of every process, who's the user that's associated
So
with
the
that process.
mapping is the kernel.
Yeah,
Okay.
exactly.
It's in the process memory.
Exactly. Yes.
So does bash check that permission, or is it
No.
kernel?
Kernel checks the permission. Yeah, so you think about, how do you even write open files for reading or write to files when you're writing in C?
Open
fopen or open or read. Those actually all call down to system calls because you as a programmer, do you want to worry about what sector this file is on the hard drive or how to parse an ext4 file system to figure out how to follow symbolic links to then... No, you don't want to do any of that unless you're writing a kernel, right? The whole point of an operating system is it abstracts that for you. So this means that the operating system on your behalf must open a file for reading or writing. And that's what will reject you and stop you from doing that. Yeah?
Yeah, are the first RWX permissions for the root user, I guess?
Yes. So for the owner, and you can tell it's an owner because of root, so we'll do another example here where I will change directory to /temp. I will, hello, to my file. I can look at my file that just got created. So here, the owner of this is nobody, and the group of this is no group. So the owner of this file can read and write it. Everyone else can read it, but can't write it or execute it, which is nice. This means that nobody can change this file.
Yeah, that's why I was asking about the other two groups. Are they for other users, I guess?
The other two, these groups, yes. So this is the process that is trying to, and it gets even more complicated, but we're not going to go into it that far. This is the process that's trying to do something to this file, the owner, the group, or anyone else.
What group?
Whatever the group of the file is. So here, the owner is nobody, and the group is no group. So,
group of users, I guess?
What's that?
Is that a group of users?
Yeah, so if you look at, EDC password, like we talked about EDC PASSWD, this is all the users on the system. And then ETC, I think it just, is it group or groups? Yeah, group. EDC group has all the groups on the system. Which is how you can do things like, so when we looked at the matrix model, we said, okay, is it possible for me to give read access to 2 users on the system and no other users with the matrix model?
Yes.
Yes. Hey, it's possible to do anything in the matrix model, right? You can express whatever access control rules you want. It's very easy. You give the rights to those 2 users you want to that specific object, and you're done. But on Unix, does it have a nice, easy way to give just 2 users access to a file?
Sort of.
Not an easy way. How would you do it?
Make a group and then assign.
Yeah, you'd have to make a group with only those 2 users in it, and then change the owner of that group, or change the group of the file to that group, and then now those 2 users can access it and nobody else. But then what if you now have another file that you want 2 different users to have access to, but one of them's the same user, you don't have to keep creating multiple groups. Or if you have a file you want to share with 3 people, that's a superset of just those 2 people, now you have to figure out how to do that, which becomes a huge pain. All right, cool. So, that was I wouldn't say digression because this all comes up. So, here in the Unix, what we care about is the process. Yeah.
I don't mean to go back, but
Please.
How exactly do they manage, like, adding yourself to a group? How are permissions there managed? Because wouldn't it just be easy if
anyone can add themselves to a root group,
Yeah.
and then it would be super easy? Yes. Okay, so let me look real quick. I can't remember which file lists all the members in the group. This lists all the groups. I don't remember actually off the top of my head. Okay, but it actually is, so I'll answer that question in a roundabout way. So, we have this file. Would you say that this etc password, PASSWD file is important?
Sure.
Why is it important? It defines all the users on the system. So if you want a new user on the system, you just add a new line to this file. Should anyone be able to add a user to a system?
Yeah.
Yes? Yeah, what kind of systems are you admitting? It's going to be a nightmare. No, I mean, usually on most systems, you want just the administrator to be able to make new users, right? Or think about a more concrete scenario. When I give you all access to one server, do I want any of you to be able to just create new users? No, I do not. Okay, but we look at this EDC password file. One of the things in this EDC password file, so the way to read this is the name of the user. The second field used to be the actual password, so it's a little bit of a history lesson, why it's called PASSWD, because it used to store hashed passwords of all the users on the system. As we'll see later, that's a terrible idea. So they moved that to EDC shadow, which I can't get to. If I do ls-la, you'll see that only root can read or write that. And the group shadow can read it, but I can't read it. So if I wanted to try to get to everybody's hashes, I can't do that. Okay. So we go back to the EDC password file. Actually, I'll just scroll up. So we have the name of the user, a password, a hash password. X means go look in the EDC password file. We have, I believe, the user ID of the user and the group ID of the user, although I'm not 100% certain. I think for most of these are exactly the same, except apparently for sync for some reason. So the idea is this is that user ID. So you think about in the kernel, do you want to keep a string for every process about what user it is? Or what user that process is? No, strings are dumb. You want to use numbers, right? I mean, they're not dumb. They just have a lot of problems, right? So use a number, and you can always go back to this file to map the number to the name. Okay. Then you have, I think this is the group, although I'm not certain, but at the end here you have their home directory. So root's in /home, or root's home is /root. And then what's this last element here?
Shell that it uses.
The shell, the default shell that the user uses. Why do you want users to be able to change what does a shell mean?
What input for commands?
Yeah, it's like the thing that you're interacting with that's parsing all your commands and then spawning a process to do your bidding and telling you, and doing all that cool stuff like file redirection, so redirecting things to files, all that kind of stuff happens there. Cool. Do you want to make, if you're an admin of a system, do you want to force all your users to use the same shell? It depends on the system. I mean, I guess if you're the military, the answer is always yes. Do you want to restrict things? The answer is yes. For a normal system, no. There's many different shells. You can run bash, you can run sh, you can run zsh, you could run, I don't know, does anybody I think fish is another one I've heard of. Does anybody run a weird one that I haven't heard of? Corn. That's actually a real one? Okay, corn, but that's like an old one. Like a cool new one. It's not a KSH? Yeah, it's like KORN, not, I think, the band. I can't remember exactly what the name relation is there. Maybe the person who wrote it or something.
I think it was like C shell, and then they were just like, oh, we'll have a K shell.
Okay, yeah, interesting. Okay, so I'm a user. So I'm user nobody. I want to change, and so here you can put, if you don't want people to be able to log in, you put it to something like this, but let's see, I do not have, so I'm going to actually get on a different system really quick. Sure, why not? Nope. Oh, you aren't letting me access to the internet. Okay. We'll see if this works. Live demos on real systems. I actually broke my system in one of the classes doing exactly this. There we go. Oh, slowly coming up. Okay. Okay, so I'm logged in as user Ubuntu on this system. This is actually the submission system that's running all your stuff. So if I look at PASSWD, I can see that the Ubuntu user is using bin bash. But man, I really, I don't think this is going to work exactly the way I want, but that's fine. We'll deal with it. No, I can't. Okay, sorry. Okay, so bin bash. So user Ubuntu shell is bin bash. But man, I really want to try out this super cool sh prompt, because look at how much better it is. Sh is such a better shell. And so, how do I change my shell?
Dash
Okay, so maybe try to edit vim edc passwd. This will not work. It's opened as read-only. There's no way to change this file. Okay, that's not going to work. Of course, vim is definitely not stuck. I think it's the network. Oh, there we go. Okay, get my quit. Good. Okay. So, I can't change that file. What should I do?
Run a process.
How do I do it? CHSH? I don't know a password. But I definitely am not going to show everyone here my password. Okay, so normally you type in your user's password. I'm going to run this as root just to prove a point, but you can change your own password. Okay, I promise that. So I'm going to change it to binsh, and then I'm going to cat edc password, and then we will see that I changed this line in this file to /binsh. How was I able to do that? Did I just fundamentally break Unix's permission model? Seems like it, right? I was able to change this line in a file that I have no write access to. Who's the only person that can change this file? Yeah, okay, but let's pretend I didn't. Just because I don't have a password. I don't know the password on this system. So, I mean, I could create a password right now and then change it, but I don't want, I have to make a good password and make sure that you all can't log into this system as this user. It's like a whole thing, so I'm not going to do that. But you can change your shell without running as user or without running as root. I promise you. How? Yeah, we need some kind of process to act as root. How did I change my shell?
You ran ch.
This is like using a really, come on. No, it's totally taking away from my point. Yeah, they're basically the same. Okay, if we look at user bin CHSH, what's different about this executable than other executables?
As the SUID bit.
It has this S here as the, instead of execute, it has an S here instead of an X. This is doesn't stand for super important, it stands for set UID. What this means is this is a special bit which says when you run this process, run it as the user that owns this process, not as the user running this process. Normally if we ran CHSH, it would run as our user, which means that it can't edit the Evc password file. But if this user bin CHSH is running as root, then it can obviously read that file and edit that value. So, what was the original question that sent me down this rabbit hole? No, that was my question. Yeah.
It was like, what's stopping you from just adding yourself to a group?
Yes. Okay. So this is what's stopping you. So, so the idea is, in order to do things like this, to give. So you can think about basically, it's like giving very limited powers to a user, right? Like you don't get full root privileges, but you can change just your shell with this program. Or you can, let's say, get added to a group. So one thing about groups is you can have a password on the group, and if you know that password, you get added automatically to that group. And anyone can do that. And that's, I think it's like, I actually don't remember the command to do that, but it's one of the commands, and it's definitely a set UID program. Cool. And this is how everything works, basically. Awesome. This is fun. Cool. Okay, so if we think about Unix, we've dispelled the notion that there's any such thing as users on the system. It's all process. So we have subjects as processes. We have files as objects, and we have the writes. So we have read, write, execute. We didn't talk about it, but there is an append. You can, on newer things, you can have append-only files. I think it depends on, I don't know if it's exactly the file system or where that happens, but So why is own a right? What do I mean by own here? Yes?
Like change who owns the file?
Yeah, you can, well, you own the file, and that gives you more privileges than if you can just read, write, execute it, right? And this is simplified because we don't have the group ownership on here either, and we don't have concepts of groups here. But still, from here, so we can think about these very simply: read, write, execute, append, own. So we can now represent, any kind of access control model in a real-world Linux system in this way. So using our super handy-dandy expressive matrix. I'm not going to go into this. So we've talked a lot about the access control matrix benefits and drawbacks, so I'm not going to go into more details here. We'll talk about how do we implement an access control matrix. So like we said, Unix, Linux, the operating system is the thing that checks, can you edit this file? Can you read this file? Can you execute this program? We even saw the crazy thing with that set UID where it will actually elevate your privileges to root just for that process that's running. I mean, so are you gearing up for technical interviews at any point soon? Yeah, so one tip for technical interviews is you should silence is weird. So if you're just sitting there, it's a back and forth communication between the interviewer and you. They want to see how you think. They don't just want to see, can you solve this problem? They want to see, can you think through solving this problem, right? Because that gives them more insight into you. So one of the things that can happen is you just you hear a problem and you just think for a while, and you're like, what about this? And then it doesn't work. One of the best things to do is to just talk through your approach. If you have no idea what to do, talk about the stupid, simplest, dumbest approach that you could possibly do. Question?
So,
Yeah.
Answer actually.
Okay, perfect. Well, yeah.
Yeah, so it seems that the columns are representing the subjects.
What's the naive way? I mean, how would you just implement it?
So as metadata to the subjects.
Okay.
That will be the columns.
So one way to do it, wait, stop for a second. So one way to do it would be the dumb way here. I mean, not dumb, I would say, the simple way, right? Simple is not bad. The simple way is you just have this matrix in the kernel, right? You can do two-dimensional arrays. Please, for the love of everything holy, nod your head. Pretend that you do, and then go learn very quickly and come back. You can do two-dimensional arrays. It's just a two-dimensional array, right? Or a hash table. It's a hash table of hash tables, basically. So you could also do it that way, right? You could do it in all kinds of ways. But you just say, and for every access, you just look up what this process wants to do. Does the process have the right to this object? Look it up in your table. What's some of the problems there?
It's very large.
It's very large, just like we talked about, right? So the operating system has to have this in memory. It's also very dynamic, as we talked about. Things can constantly be changing. So you have to worry about issues to do with parallelism. What happens if multiple process tries to interact with this table at once? So you probably want to serialize access to the table, and then you get to all these crazy problems. So how else could you implement it? Have it as a part of the file. So for each file, how would you do it?
So,
I mean, not super detailed, well, I changed the I know to do this at a high level.
each file will have owner. So the owner can do read, write, own, and then there will be probably another column for other or group.
Okay, but let's go a little bit higher level than Linux. And let's say we want to be a little bit better than Linux in some sense, right? And to say, okay, well, what if we want it, rather than collapsing everyone into this owner group or everyone, what if we wanted to keep track of what every user can do on the file?
Maybe have just every user who can do stuff to it, just have it in there, and then have owner
what aspect of this table is this?
The subjects.
So for every file, so for F, what are you going to store on F?
PRWO and then QA.
Yeah, so that column, right? So for every file, you think about the column, and you store with every file the rights of every user on that file. Thoughts?
Doesn't scale.
Doesn't scale, how so?
Have many users.
With many users, yeah. And so what happens when you add a new user to the system?
You have to do one for every single one.
You have to go to every single file and update every file to add that metadata that this user has those rights.
Does that data also transition to other systems as well?
Yeah, that's a huge, I think, a general purpose problem that we'll ignore for now of how do you, and this happens if you've ever run like an NFS file share or a Samba share of like dealing with access control between Unix and Windows. It's like a huge thing. Yeah.
Is there like if we store like that metadata with the file, isn't there like a security problem? Like if you're able to edit that file?
Yeah, so we definitely need to make sure that the metadata is not accessible. If we just said, well, the first part of every file will store 100 bytes of the size of this column that we need, well then every application, if they're reading that file, if they read those 100 bytes, they can just change it and add stuff. So we'll assume that we're doing it in such a way that a process itself can't change its list. Yeah. What are some other thoughts on this model? It's, I guess, less of a model, more of kind of like an implementation.
You have each user get their own like access table.
So, say it again?
So like each user, instead of having there's like a table of files, and each user has their own like access table. So permissions.
So then, rather than thinking about it in terms of columns here, think about it in terms of rows. So for each user, store metadata about what files that user has permissions on. Yeah.
Yeah, if you add kind of append the data to the file, then you modify the file. You don't really want to do that with any different systems.
Yeah.
You
What's
want
the slowest thing on a computer?
Right.
Probably the user, actually, now that I say it. But what's the second slowest thing? It's actually a fun game. I'd say no, not disk.
Logging on? No.
Still user logging on. Not hard drive. What's the fastest thing?
CPU.
Yeah, CPU or like even transistors if you want to get that level. What about network? Is the network slow?
Yeah.
Yeah, like network communication. So I'd say the user, network communication. What's after that? I'd say storage, disk. Yeah, disk. Disk is super slow. I mean, spinning disks are really, really slow. SSDs are, by comparison, very fast, but still very slow. So you think about a model where you have, like we talked about with the columns, where every file, so you had a new user who has read permissions to every file in the system. You now have to go and write and change something in every single file on the system, or the metadata associated with every single file on the system. You're going to kill your hard drive and probably end up killing it early. So that's how. So the other way of what we talked about is, well, for each user. So then let's go that direction. So let's say, okay, the operating system, rather than creating this huge table, then just thinks about, well, for a specific user or specific process, or I guess subject, if we're going back to this model, you'd store the rights to all of the files for that user. So what are some of the benefits there, or drawbacks?
Drawbacks again, make more files, gets bigger.
And every time a file is created, you have to update that for all the users on the system.
It's users created.
What was that?
Every time a user is created, you have to go through all the files.
Yeah, every time a user is created, you have to go through all the files that they have rights to. I'd say that between the two, file creation is a much more frequent event than user creation, and especially because you have lots of temp files being created all the time. Yeah.
User deletion, if they're the only user that has access to a specific file, and we have something that's just going to sit there forever.
Yeah, that's an interesting case. Yeah, you had this case of what, like orphan files, right? Where you delete a user and now these files are just hanging around. Cool, good discussion. So, you just invented 2 different models of access control. Look at this. Yes, awesome. So access control lists are exactly what they sound like, and this is exactly what we talked about, where each column of the access matrix, you store that with the object. So one of the nice things here is, what do you do about a user who has no rights to a file or an object?
Deny access to whatever they're.
Yeah, you do default deny and you would not store anything there. Like you don't store, well, foo has 0 rights and bar has 0 rights, right? Because then you're just wasting space. So that is a nice thing here. And so the flip side here is thinking about this, and again, it's just slicing this matrix in different ways. So the capability lists are exactly what we talked about. So it's thinking about, and the way to think about this is, okay, an access control list, like on a file, there is a list of who can access that file and what rights they have. Whereas a capability list is what capabilities does a specific user have? What capabilities do they have to the objects? And this is just rows. So it's very simple, exactly what we talked about. I don't like that. Okay, and we've actually talked about some of the interesting parts here. So in order to do an access control list, you need to be able to authenticate subjects. Why is that? Yeah.
To figure out who's accessing the file.
Yeah. Otherwise, I'll just lie and say that I'm the root user. Like, give me all the access to this file. Capabilities. So, assuming you do it correctly, so if we go back, capabilities are what we talked about where each user has a list. The kernel can actually even give you this list in an, we'll talk about some crypto things later in this course, in an unforgeable manner, so that you can't change it, but they can the kernel can verify that yes, these capabilities are legitimate and are really you. So this means that you don't need to authenticate them every time, but you need to be, there's like a lot of caveats. If you can just, it's like a key, right? Like a physical key. You can give a physical key to somebody else and they can copy it and give it to somebody else and copy it. You can't control that propagation. But if the operating system can control that, then you can do some cool stuff. Yes, okay, this is exactly what we've been talking about. Cool. Okay. They are very... So one of the nice things is if we think about the access here, and we think about, okay, with capabilities, you could actually voluntarily get lower capabilities. So if you wanted to say, well, I actually, bless you, if I actually don't want to write to this file, I just want to read to this file, then that's very easy to do with capabilities. You just say, well, remove these capabilities because you're just getting, like, restricting yourself. Why would you want to do that? Is restricting yourself fun? Your capabilities? Yeah.
If it's a crucial system process, I may not necessarily want to be able to mess with it, but I may want to see what it's doing.
Yeah, exactly. So think about, well, we haven't got there yet, but you need to be root on a Unix machine to bind to ports below, I think it's 1024. It's like, what port is web traffic on? Port 80, which means who can bind to port 80 on a Unix system? Root. Which means your web server must run as root in order to bind to that port. Do you want your web server where anyone on Earth can contact it, which has possibly remotely exploitable vulnerabilities, running as root? Oh, definitely not. That's actually that www-data user I think that we saw earlier. So there's a way for, well, it's actually a lot of ways, and Linux actually has a capability system so that you can say, I want to run as root, but I only want the ability to, like, I don't know, open a socket. So you can't do all root capabilities, you can just do one thing. Or like this, where you just want to be root to open the socket, and then you want to change to a different user, essentially dropping your capabilities. So capabilities, and this is, again, here we're kind of, when we talk about the differences between access control lists and capabilities, they're they're two different views of the same model, right? So fundamentally they're the same, and it really comes down to kind of fine-grained things of when some things can be better. For instance, like if we wanted to create some process to just do one thing to one file, we could give it the capabilities to only touch that file. And we know if it goes rogue and starts trying to delete all the files, it fundamentally can't because it doesn't have that capabilities. Do you want to know if you're administrating a system who can do what?
Yes.
Yep. Why? You have this beautiful model of all the access control rights of every user in your system, right?
To verify that
Yeah,
the system's actually...
to verify that the system's in the state that it should be in, right? This is something that if you're taking this thing seriously, or you think about a company, we think about access control in terms of physical access to the building. What are some cases you would want to detect? Password changes? What else?
File removal. File removal.
File removal? What about who's accessed the building who's not an employee? Right? Who has access to the building, and you'd want to correlate that with who's actually an employee. Are people's access getting revoked when they should? You think about like the Isaac access system, that's another thing. I think to deal with that, they just restart everyone every semester or something. And so you have to reapply for access if you need access. So for access control list versus capabilities, if you want to review who can do what, what's easier? Yeah.
Maybe capability lists, since you can just see the users and what they can do.
Exactly. You look at every user's capabilities on the system, and you'd say, okay, yes, these are, this is who can do what. And it actually kind of depends on your capability, or on what you're trying to do. If you actually want to ask, well, who can edit important files on my system, or important objects on my system, then in that case, that's kind of a pain because you need to go through every subject to see who can do what. When in an access control list, you just look at that object and you say, oh, okay, these are the subjects that can edit or that can have these rights. What about revocation? What does revocation mean?
Take something away from you?
Take something away, yeah. Follow?
Innovative a little, like moving what the plan is putting it up.
Close. It's more, I think more of the taking away connotation. Like if I revoke somebody's A from a semester ago because I found out they're cheating, right? That would be taking something away from them. And so in the context of access control, what do we mean by revocation? Yeah, remove someone's access to the system. So we just talked about with Isaac, how do I remove their access to the system? Is it just taking their, so has anybody moved apartments before? How do they ensure that your access to that apartment has been revoked? Do they do what?
You give the keys back to them?
You give the keys back to them.
And they might change the lock, I don't know.
I mean, if you just gave the keys back to them, are they sure that your access has been revoked?
No, because you can copy those keys.
Yeah, because you can copy those keys, right? Even if it says do not copy, there are ways definitely to make that happen, right? So that doesn't guarantee it, but what does?
Changing the locks.
Changing the locks, right? That's what a good landlord would do, is after somebody moves out, you change the locks. That way you don't care if they've made keys, you don't care about whatever, you just, you do that. So then, for access control or capability list, which is better for revocation? what
Access
circumstance?
control.
Was that?
Access control.
Access control lists? Why?
Well, because if I don't want user A to access this set of files, I can say, hey, you know, user A on this set of files is there's.
Yeah, you just update the files there. The tricky thing always comes in as to, well, what do you, like we talked about, well, if you want to, let's say, remove their access to all the files, you have to go and update every single file in the system. So it's, again, all these things are kind of matters of perspective and matters of, there's no hard and fast answers of what is definitively better most of the time. And again, it's very similar because you're storing all of the access rights on each of the objects. If you want to remove access to a specific object, it's very easy with an access control list. More difficult with a capability list, but again, you can do everything. Okay, cool. Yeah, we did this. We'll come back to it. That'll be a good refresher. Let's see. What do I want to do? We have 3 minutes with you. Okay, cool. We'll finish this up then. Okay, so capability lists. So access control lists are pretty easy. If we want to give somebody access to our file, how do we do that?
We add them to the file.
Yeah, we add them to the file's metadata to say, okay, this user gets access to this file. The operating system would probably check, do we have that ability to add or change that access control list on that file? In Unix, that would be the owner privilege. For the owner of that file, we can control that. Actually, as the owner of that file, we can give ownership of that file to somebody else. How do we do it in capability lists?
If we wanted to grant access to a file,
Yeah.
you'd update the user's permissions for that file.
Yeah, so we'd have to either basically, I mean, we may not be able to do it ourselves, but we'd have to tell the operating system, update the capabilities for this other user, and then have to somehow notify that user that they need to refetch their capabilities because their set doesn't contain that file, so they wouldn't have access. So, anyways, so basically, and you could do it a number of ways. One of the cool things about capability lists is you can create a system such that one user P can create their own capabilities to give out to somebody else. So if P has owner rights on file F, they can actually create a capability without invoking the operating system to give to process Q so that they can give it to the operating system and say, hey, look, I got this capability from Q who says I can now read to this file. And then everything will work, which is pretty cool. So you can do things like pass this stuff around. So what does Unix implement? Which of these styles?
Capability list.
Access control.
Technically both, but the normal thing we're used to thinking about is access control lists, right? And why is that? Or how do you know that? Let's rephrase
It
it.
has that metadata on the individual files.
Yeah, we saw that when you do ls-la, right? There's metadata on each individual file that the operating system is storing on each file. Now, is it storing every single subject on the system, what they can do to that file? No. What is it storing?
Groups. Groups, owner, and root.
Owner, groups, and other. Yeah, owner, groups, and other, along with who's the owner and who's the group of that file. Why? Why do that? Can you, like we just talked about, it's difficult to express everything you might want to express there. It's difficult to say things like, oh, I just want to share this file with these 3 people or these 4 people without creating all kinds of crazy groups. So why do that? Yeah.
It simplifies it from an administrator perspective. That way I don't have to go and start digging through just to make certain that user X has access or does not have access to this file.
So maybe one idea would be user experience of the administrator to understand and reason about things. I'd say that in general a simpler system would be easier to reason about. Yeah, what else?
To avoid the blowing up thing.
What blowing up thing?
Well, like, if there's like a million users, you want access to that.
Yeah, if you have a million users that you have to give access to, you have to have some way of representing that. So for a file that is readable by everyone, you need at least 1 bit per user on your system. And if you're talking about huge systems with lots of users, that's a lot of file metadata. How many bits do you need with the current scheme? 10? How do you reason?
I guess it's 10 bytes.
At least how many?
3 for each group.
3 for each group, or 3 for each, let's say, access control write groupings. So a read, write, execute for owner, group, and other, right? So 9 bits, which is not a lot, and there's other bits in there that do other things. So at the end of the day, you just use 12 bits for each file, and you can still express all of this complicated stuff. But again, you're giving up expressivity. You cannot express everything that you can in a typical access control list. All right, good stuff. See you on Tuesday.